Hey guys, alright, today we are going to open up to page 5, okay? And we're going to do this little recap together, okay? So on page 5, the top says, list the perfect squares. So a perfect square number is a number where you have the same number times itself. Ooh, that's really thick, sorry. So in this case, 2 squared would be 2 times 2, so 4 is a perfect square. 3 times 3, 9 is a perfect square. 4 times 4, 16 is a perfect square. 5 times 5, 25 is a perfect square. 6 times 6, 36 is a perfect square. 7 times 7, 49 is a perfect square. 8 times 8, 64 is a perfect square. 9 times 9, 81 is a perfect square. 10 times 10, 100 is a perfect square. 11 times 11, 121 is a perfect square. 12 times 12, 144 is a perfect square. 13 times 13, 169 is a perfect square. 14 times 14, 196 is a perfect square. 15 times 15, 225 is a perfect square. So these numbers that are in yellow are called perfect squares. So if we ask you to try to find a perfect square, you're looking for one of the numbers listed in this yellow row right here, okay? So when we look at this page, right, question number 1, it says simplify. When I simplify a radical, this little piece is called a radical, right? When I simplify a radical, what I'm looking for is if any of these perfect squares listed up here is a factor of the number under the radical. In this case, we're trying to find if there's any perfect squares that are factors of 108. Now, instead of just looking for any old perfect square, you're trying to find the largest perfect square that's a factor of 108. So let's go ahead and go into our calculators, right? And we're going to go to a graph page. And we're going to type in 108 divided by x, okay? And we're going to look at the table. Now I'm scrolling through this table to see if there are any perfect squares in here. So I'm looking for any of these yellow numbers, the yellow row, listed in the Y column here. And it looks like 108 is not on the list, 54 is not on the list, 36 is on the list. So he's going to be the largest perfect square that is a factor of 108. Now I'm going to look for his pair, which is radical 3. So what I've done is I've split up this radical into 2 radicals, right? And each radical is a factor. And if you multiply these 2 radicals together, you would end up getting 108, okay? So the square root of 36, the way that I find the square root of 36 is I go to my calculator, I go to a calculator page, I hit Control blue for square root. I type in 36 and I see that the square root of 6 is a nice integer. An integer is a whole number. Whereas the square root of 3 is not a nice number. If I type it in, look what I get. I get a disgusting decimal, so he is not a rational number. So therefore, I'm going to leave the square root of 3 under a square root, and then I'm going to keep the 6 out front. So my answer is 6 times the square root of 3. I can't pause the video, I'm sorry. So we're going to go to number 2, and I'm looking at the factors of 96. I'm going to look for the largest perfect square that is a factor of 96. So I'm going to go to the table and I'm going to scroll. 96 is not a perfect square. 48 is not a perfect square. 32 is not a perfect square. 24 is not a perfect square. 19.2 is not a perfect square. 16 is a perfect square. So 6 times 16 gives me 96. I'm going to put the perfect square first and the irrational or non-perfect square second. The square root of 16, I could either type it into my calculator, I could just use the chart, it's 4. Okay, we're going to keep going. Simplify, 3 times the square root of 162. I'm going to type in 162. Hold on, I'm going to start a new document because otherwise the table gets weird sometimes. 162 divided by x. Now I'm going to scroll through the pairings here. I've got 162. He's not a perfect square. 81 is a perfect square. That's what I'm going to pick. So I have 3 out front. I'm just going to leave him where he is. The perfect square goes first, and then what was the number that it was multiplied by? 2. And the irrational number goes last. So now I would simplify this. I would get 3 times, the operation in between 3 and the square root symbol is going to be multiplication. 9 times the square root of 2. 9 times 3 is 27, and my answer is 27 square root of 2. Let's say I wanted to check and see if I was right. I'm like, all right, 27 square root of 2, cool, but like I have no idea if I'm right or not. You can always just type it in a calculator page and check. Is that the same as what they gave us originally? 3 times the square root of 162? It is. We are so smart. Okay, let's go to the last one. We have simplified -5 times the square root of 75. Well, let's type in 75 in a graph divided by x. Pull up the table. All right, 75 is not a perfect square. 37.5 is not a perfect square. 25 is a perfect square. So out of the square root of 25 times the square root of 3, and then there was a -5 out front. I'm going to do the square root of 25, which is 5, times the -5 out front, and then I leave the square root of 3 under the radical because he is irrational. -5 times 5 is -25 times the square root of 3, and that is my answer. Let's say I wanted to check that answer and see if it's right. I would go to a calculator page. I would do -25 times the square root of 3. That's some strange number. Let's type in the original, -5 times the square root of 75. It's the same strange number, so we good. All right. Last, rational versus irrational numbers. The square root of 25 compared to the square root of 30. Well, first let's talk about what a rational number is. A rational number is a number that can be written as a ratio of 2 integers. So if I have a nice number, say 10, I could write that as a ratio of 2 integers if I wanted. I could just put the 10 over 1. These are equivalent forms. What if I had 3 over 2? Sure, he's a ratio of 2 integers, 3 and 2, okay? So anything that can be written as a fraction is kind of like the layman's terms of knowing what a rational number is. And then an irrational number is something that can't be written as the ratio of 2 integers. For example, famous irrational numbers include pi, the square root of 2, any decimal that goes on forever and does not repeat. Look at this. He goes on forever and he doesn't repeat. He does stop because the calculator isn't going to keep going on forever. It kind of cuts it off at a certain number of digits. Square root of 2. Again, he's irrational. How can I see that he's irrational? You could just double check and be like, is the calculator rounding or is this a real decimal? You could hit the up arrow, pick up the decimal, hit enter, and if more digits come up, like in this spot right here, you will know that it is in fact an irrational number. So if I pick up pi, look, he ended at 359, I hit enter, 35898, that shows me that they rounded it to get to this spot here, okay? So an irrational number goes on forever and does not repeat. Why does it go on forever and does not repeat? Okay, check out like, check out like 1 over 11. Okay, so this is a decimal that goes on and on and on forever. I pick it up and it keeps going. But this is just rounding, right? It doesn't repeat, it just keeps going. Another example could be, I think, 1 divided by 7 is a good one too. Ooh, no, I don't want that. 1 divided by 7. Okay, so that guy repeats, right? Look at the pattern. 1, 4, 2, 8, 5, 7. 1, 4, 2, 8, 5, 7. So these are rational numbers because I can write them as a ratio of 2 integers. 1 over 11, 1 over 7. But their decimals repeat, so that's why they are not irrational even though they go on forever. So it needs to have these two conditions. It can't be written as a ratio of 2 integers, It goes on forever and it does not repeat, okay? So the square root of 25, he's a nice number, he's 5. I can write 5 as a ratio of 2 integers, whereas the square root of 30, he is not a nice number. He ends up being, I don't know, let's type it in. Gross. Let's pick it up and see if it goes on forever. It does, okay? So we would just say, goes on forever, doesn't repeat. Okay, great. Your classwork today is going to be going through the 7.1 Simplifying Radicals practice. I'll get you started and then hopefully you'll be able to see what you should do, okay? So let's start here. We have the negative square root of 20. I can break him down as the negative square root of 4 times the square root of 5. If that's not readily available to you in your brain, you could always type it in, go to the table, and figure out what these two numbers should be. So I take the square root of 4, it's 2, there's a negative out front, 2 rad 5. I'm going to follow this 2 rad 5 to the negative 2 rad 5 that's down here. I end up in this box. So the square root of 125, I'm going to break that down into the largest perfect square. That's a factor of 125. What if you didn't know what to do? You could graph this. You could look on the table. All right, I'm going to scroll until I see a perfect square. 125 is not a perfect square. 60, you can just skip all the decimals. Ooh, 25. 5 rad 25. So I put the perfect square first. I put the irrational number second. The square root of 25 is 5, rad 5. This is the next one I'm looking for, so right over here. So now I'm in this box, okay? So you're going to keep going until you get to the end. All right, good luck.